Good day, everyone. In partial fulfillment of the requirements in CE22 Engineering Economics course under UP Institute of Civil Engineering, we are pleased to present to you our group project entitled Road Rehabilitation of the MacArthur Highway along Longos, City of Malolos, Bulacan, which aims to address the design problem of the pavement of the said study area. Before we begin, we would like to introduce the proponents of this project. Hi, I am Team Joshua Cruz.
I am Jasper Dela Cruz.
I am Lennard Ching.
I am Ranz Gabor.
And we are civil engineering students from the University of the Philippines, Diliman.
The project analysis presentation will be discussed as follows. First, the background of the problem, then the proposed project alternatives, followed by the evaluation of alternatives, and finally the chosen alternative and recommendations. Government-funded construction projects are essential in improving the livelihood of its citizens. However, there are cases in which quality is sacrificed to tighten the budget allocation by subpar adherence to standards and ideal design. An example of this is the premature deterioration of roads along MacArthur Highway in Longos, Malolos, Bulacan, which has caused inconvenience to road users. With this, the project aims to address the design problem in the roads along MacArthur Highway in Longos, Malolos, Bulacan by providing a more efficient and economically sound alternative. MacArthur Highway, officially known as Manila North Road, is a 2 to 8 lane national road that stretches from Caloocan in Metro Manila to the northern province of Ilocos Norte. This study only covers a total road distance of 1.75 kilometers and width of 13.4 of the MacArthur Highway from Longos intersection to Gardenville subdivision. Listed in the slide are the project limitations. This study is only limited to the specified length of the MacArthur Highway. Economic analysis used to determine the best alternative were the benefit-cost ratio method, incremental analysis, and simple multi-attribute rating technique with assumptions as shown in the slide.
To address the problem, 3 alternative pavements were proposed: asphalt concrete, concrete, and pervious concrete. Asphalt concrete is a type of flexible pavement made up of aggregate, sand, additives, and liquid asphalt. It is commonly used for driveways, parking lots, roadways, airstrips, and more, being known for its durability and resilience in handling heavier loads. Asphalt concrete pavement is also perceived to be safe and smooth, which contributes to a better overall riding experience, operating cost, and travel time. The design and pricing of materials for asphalt pavement was adapted from the Cavite-Laguna Expressway project under DPWH.
Concrete pavement is a type of pavement that is commonly used in the Philippines. It is known for its durable qualities and life expectancy of about 20 years. It only uses basic construction materials and it does not need frequent major maintenances throughout its lifetime. Even if the construction takes more time, money, and effort, with the right rebar supports and subgrade and sub-base course, concrete roads will be able to provide the service that is needed in an area.
Pervious concrete is a type of concrete pavement comprised mostly of well-graded coarse aggregates and cementing ingredients that form an interior macropore structure. Water can flow through permeable pavements, which are made up of pervious concrete, paving stones, and interlocking pavers. Because of their porous nature, they can be a viable alternative. However, due to having more coarser aggregates in their mix, this pavement tends to become weaker and less stable.
To determine the best alternative economically, the alternatives were evaluated by cash flow development, cost analysis, incremental benefit cost analysis, and multi-criteria decision analysis. Following literature, it was determined that the initial cost totals to around 77 million pesos, annual maintenance costs to 11 million pesos, periodic maintenance every 5 years totals to 12 million, while the perceived economic benefits, which includes annual pavement life extension, vehicle operating cost savings, travel time cost savings, and road accident prevention savings, amounts to around 12 million per year. The present value was obtained with an interest rate of 10% and assuming infinite service life. The benefit-cost ratio was obtained using the formula and discounted cost and benefits displayed, which results to a value greater than 1. Thus, the asphalt concrete pavement alternative is considered as economically viable.
We can see in this slide that the initial cost for construction of concrete pavements amounts to about 43 million pesos with an annual operation and maintenance cost of about 3 million pesos. Additionally, a periodic maintenance should be conducted which amounts to about 1 million pesos. The benefit of using concrete pavements can be valued at approximately 10 million pesos. All of these were analyzed with the MARR considered at 10% and an indefinite life cycle. Computing the benefit-cost ratio, we obtain a value of 1.182 with n as infinity. Since the value of B to C ratio is greater than 1, we can see that the alternative is workable.
The economic analysis of the students from UC Davis provided important details about the investment cost for the Pervious pavement. As shown, the initial cost is estimated to be around 87.2 million pesos. The yearly operations and management costs are about 4.7 million. Every 5 years, there will be a 195,000 expenses for restoring the permeability of the pavers, while every 25 years, 4.5 million will be spent for refreshing the base course. Benefits are estimated to be 14.5 million annually. Following the modified BC ratio analysis, the respective present worth values were obtained with 10% MARR value. Following the formula presented, the calculated BC ratio is 1.077, which signifies that the alternative is economically feasible. Initial economic analysis proved the three pavement alternatives to be economically viable options. To determine the best alternative in terms of cost and benefits, incremental analysis with a study period of 25 years was used. Following the defender and challenger approach, with AC versus concrete first and Pervious versus concrete second, the concrete alternative was determined to be the best option as a material of the surface course for the pavement.
In recognition of factors defining the best alternative based on the research interests that were not included in the economic analysis, the proponents established criteria, namely cost, safety, completion, and environment with a normalized weight of 60, 20, 10, and 10 respectively. Following economic analysis and previous studies comparing the three alternatives, each alternative was rated in a scale of 1 to 10 for each criterion. The concrete pavement option obtained the highest rating for cost as proven by the economic analysis executed in this study. On the other hand, the asphalt concrete alternative got the highest rating for both safety and completion criterion because of its high skid resistance, durability, and construction process. Lastly, the Pervious concrete pavement option acquired the highest rating for environmental impact due to its design and effectiveness in mitigating flood and thermal pollution.
The three proposed pavement design alternatives were proven to be viable through economic analysis based on the estimated benefits and costs. Implementation of any of these alternatives will be advantageous for the reconstruction as the benefits weigh out the costs. This study, however, aims to find the best design alternative. By utilizing incremental analysis and simple multi-attribute rating technique, the three proposed alternatives were compared, and it was determined that the most economically efficient design is with the use of concrete pavement. This agrees with the fact that concrete is the most commonly used pavement type in the Philippines. As stated in the scope and limitations, this study only covers a specified length of the MacArthur Highway in Longos, Malolos, Bulacan. Future related studies can be done in other countries, especially where the climate is different. One disadvantage of the concrete pavement is its vulnerability to the freeze-thaw cycle, which is only considered in countries that experience winter seasons. Furthermore, a wider range or a selection of more specific pavement design alternatives may be used in future studies for the purpose of developing new and improved pavement designs which may be economically viable. That concludes our presentation for the proposed project entitled Road Rehabilitation of the MacArthur Highway along Longos, City of Malolos, Bulacan. Thank you for listening.